So that's what happened on our last one. We just had to cancel out the x minus 5 after factoring, and then we end up with x plus 2 equals 7, and we're done. Now there's one more case that you're going to see on your homework where if you can't factor, but maybe there's a root, try multiplying by the conjugate. And we're going to look at an example like that in just a minute. So what I'm going to do now is I'm going to look through the 3 examples that are on the first sheet of your limit section of your packet, and we're going to talk through those, and then you should be able to do all of the limits that are in your packet. So first out, we'll start with an example that has a root in it. And this one actually, sorry, I had to go back and remember what this was because there's no conjugate here. But this one, we're just going to try plugging it in. Okay, so it'd be root 3 plus 1 over 3 squared minus 1. So that is the square root of 4 over 9 minus 1, which is 2 over 8. That's 1/4. So we got a number. So this was our first strategy. We plugged it in, gave us a number, we have our limit. If you were to graph this, I have no idea what this graph looks like, but as you get close to 3, if this is 1, you're going to be getting closer to 1/4. So just guessing what this looks like, I'm not really sure. Maybe it comes down like this at that point. So as you get close to 3, the y values get close to 1/4. Okay, and you just get that by plugging it in. So plugging it in is definitely the easiest strategy. Let's see what else we can do. So this guy, if we plug in 1 on the top, 1 plus 2 or 3 minus 3 is 0. Looking suspicious. On the bottom, we also get 0. So this guy, let's see if we can factor it. So we'll have the limit as x approaches 1. On the top, looks like we have x and x. 3 I can only get with a 3 and a 1. And we need one of them to be positive. Looks like plus 3 minus 1 will get us to positive 2. And then on the bottom, x squared minus 1 is x plus 1. X minus 1. The x minus 1's cancel. Nice. So now when I plug in 1, I won't get that 0 over 0. So when I plug in 1 now, I'll get 4 on the top, 2 on the bottom. Looks like that is 2. So this would be a hole. If you were to graph this, you would have a hole at 1, 2. Maybe a hole like that. And then, let's see, this guy has asymptotes at negative 1, because positive 1's just a hole. So this is back to our rational function graphing. Oh boy. And it looks like we have a 0 at 3. So my bet is that this comes down like this. And then as we go to infinity, oh, I must be wrong. Because as we go to infinity, we should approach the horizontal asymptote of 1. So I'm not sure exactly what this graph looks like. I'd have to think more about that. But it looks like we come down through, and then we are going to somehow approach a horizontal asymptote of 1. But there's a 0. Oh, the 0 is at negative 3. That's why. Fransky. So 0 is at negative 3. There's no 0 here. We approach a horizontal asymptote of 1. So it's going to come down through the hole and then approach the asymptote like that. So we wouldn't have this guy at the bottom. And that's definitely not a 0. And then over here probably will look like this. There we go. So we have that hole right there. But as the x values approach 1, the y values are getting really close to 2. Because we cancel that out, we just have a hole there. Now we get a conjugate 1. So if we plug in 0, let's see what we get. We get 1 minus the square root of 1 plus 0, which is the square root of 1. And then at the bottom we have 0. So this is 1 minus 1 over 0, which is 0 over 0. So we get that 0 over 0. We can't factor this, though. So let's try multiplying by the conjugate. So the conjugate, remember, we talk a lot about complex conjugates. In this case, we're starting with 1 minus root 1 plus x. So I'm going to multiply by 1 plus root 1 plus x on the top. And if I do it on the top, I got to do it on the bottom. So on the top, we're going to have to FOIL. 1 times 1 is 1. 1 times root 1 plus x is positive root 1 plus x. 1 times negative root 1 plus x is minus root 1 plus x. And that's the point of multiplying by the conjugate. They just cancel. Then negative root 1 plus x times positive root 1 plus x. When you multiply a square root by itself, the root just goes away, but it'll still be negative. So it'll be negative 1 plus x. And that is divided by, I'm just going to leave this factored. X times 1 plus square root of 1 plus x, because I think that's going to make my life a little easier. So on the top, let's look at what we have. The 1 minus 1 will cancel, so I have a negative x on top. And on the bottom, I have x times 1 plus root 1 plus x. Hey, check it out. An x cancels. There we go. So that is negative 1 over 1 plus root 1 plus x. And if we evaluate that at x equals 0, So we're going to evaluate that at x equals 0. This is a little bit of calculus notation. We're evaluating it at x equals 0. That would be negative 1 over 1 plus root 1, which is negative 1/2. Oof. So the root one's a little bit tricky. Got to multiply by a conjugate. Not the most fun, but it doesn't kill you. It's not the end of the world. Okay, so we multiply by the conjugate, and then we just plug it in after we end up canceling that x, and we get negative 1/2 for that limit. All right, so your homework is to finish the white packet. So you're doing the rest of the limit problems. Shouldn't be too bad. I think you shouldn't have too much trouble with that. Just look through these examples again if you need some hints. It starts off with some infinity ones. Just don't forget, you do the degree of the top, the degree of the bottom, and you see which one is bigger. If it's bigger on top, infinity, bigger on the bottom, 0. Same, you look at the leading coefficients. So I'll be checking your homework tomorrow, page 749, which I was assigned yesterday, and then also the entire white packet. The sigma stuff, I know some people have been struggling with that a little bit. I've been getting some emails. We can talk more about that tomorrow, but if you look at the answers online and you struggle through it a little bit, I think you'll be able to figure it out. So do take a look at that, try it, give it your best shot, and we'll talk about it tomorrow if you still have questions. I love you guys. That's why I'm here. Have a great day.